Okay, so I want to do a physics problem today. Now, the problem is a major leaguer hits a baseball so that it leaves the bat at a speed of 30 meters per second and at an angle of 36.9 degrees above the horizontal. You can ignore air resistance. A. At what two times is the baseball at a height of 10 meters above the point at which you hit the bat? B. Calculate the horizontal and vertical components of the baseball's velocity at each of the two times calculated in part A. And C. What are the magnitude and direction of the baseball's velocity when it returns to the level at which it left the bat? Okay, so first let's write down what we know. We know the initial velocity. V0 is equal to 30 meters per second. Okay, we know the angle. Alpha is equal to 36.9 degrees. Okay, and now we're also going to specify some directions. We're going to say that the up direction is equal to the plus y direction. It's a terrible y. That's a terrible plus. Okay, so which would mean that the acceleration in the, oh, that looks like an alpha. The acceleration in the y direction is equal to, oh, come on, negative g. Sorry, I'm having so much trouble with this pen. Okay, so we know this stuff. Okay, so we're going to use the height equation, or the y distance equation, I should say, to calculate the time. So that's y is equal to v0y times t. And then remember that a sub y is negative g, so we're going to have negative 1/2 and then gt squared. Okay. So now we know everything in this equation except for the times, which we're trying to calculate, and v0y. Okay, so we can calculate v0y pretty easily. So we just say that v0y is equal to v0 times sine of alpha. So v0y is equal to 30 meters per second times sine of 36.9, which is equal to approximately 18 meters per second. Okay. So, alright, there we have that. Okay, so now we can plug in the information we know into the y distance formula or equation. Okay, so we know that we want to calculate for 10 meters, and that's equal to v0y, which is 18 meters per second, times t minus 1/2 g, which is 9.8 meters per second squared, times t squared. Alright, cool. Now, this is a quadratic equation, which we must solve for t. Alright, so pretty much I'm just going to write it in descending form, or descending order of the exponents, and I'm going to subtract 10 meters from both sides. So we're going to have negative 1/2 times 9.8 meters per second squared times t squared plus 18 meters per second times t minus 10 meters. And that's all equal to 0. Alright, great. Okay, so now I'm just going to erase this other stuff here because we already know what this stuff is. I mean, we already calculated that stuff, so I'll just get rid of that. And actually, just move this up here. Yeah, that's good enough, I guess. Unless sorry, that's like taking kind of long. Alright. Okay, good. Now, pencil. Alright. Just draw a line there. Okay. Yeah, seems my pencil's very thin now. And just get that back real quick. Size. I guess that should be about right. Okay, so anyway, now we can go about solving this quadratic equation. So we're going to say t is equal to minus b, which is minus 18 meters per second. Okay, then plus or minus the square root of b squared, which 18 times 18 should be about 324. Okay, minus, now 4 times AC. So 4 times, well, first off, let's see the sign. The sign is going to be, we've got here negative, and we've got a negative. So this is A and this is C. Okay, so that's going to be negative times negative is positive times a negative, because it's negative 4 AC. So now we're going to definitely have this negative sign here. Okay, so now that we know that, now we can multiply. So 4 times 1/2, which is 2. So 2 times 9.8 is 19.6. And 19.6 times 10 is 196. Okay. Alright. Yeah, it's terrible handwriting, sorry. Anyway, so, okay, so now, of course, this is all divided by 2 times A, which is negative 1/2 times 2 is negative 1 times 9.8, so it's negative 9.8. Okay, so negative 9.8 meters per second squared. Alright, so now, let's see. Okay, so we can just split this up, so that's 18 divided by 9.8. Okay, 18 divided by 9.8 is about 1.84. It's positive 1.84 seconds, because negative divided by negative is positive, as you know. Plus or minus. Okay, so what is the square root of 324 minus 196? That's what we need to know now. Okay, let me see, let me think. 324 minus 196. Okay, about 11 point something, 11 point, I guess if we round 11.3 approximately. Okay, now 11.3, let's think, divided by negative 9.8. Okay, that should be about 1.15. Cool. Okay, so negative 1.15 seconds. Alright, so now we're going to have that So it's 1.84 seconds plus minus 1.5 seconds. Okay. So 1.84 seconds basically minus 1.5 seconds is about 0.69. Okay. Alright, so now, let's see. Okay, so now 1.84 seconds minus 1.5 seconds, so it's plus, so 1.84 seconds plus 1.15 seconds should be 2.99 seconds about. So that's a terrible 9. Okay, so these are the 2 times at which the ball is 10 meters above the point at which you hit the bat. Or left the bat, I should say. Okay, so we've got those 2 times. Cool. So that was part A. Terrible. Why am I having trouble with this? Whatever. Anyway, okay, so that was part A. Alright, now we can start part B. Okay, so part B again was, let's see, calculate the horizontal and vertical components of the baseball's velocity at each of the 2 times calculated in part A. Okay, so let's see now. So we know that time 1 was equal to 0.69 seconds and time 2 was equal to 2.99 seconds. Okay, so now we need to calculate the horizontal and vertical components at each of the 2 times. So let's start with the horizontal components at each of the 2 times. Alright, well, we know that the horizontal components at both times, and in fact at all times, would just be the initial x velocity. So we would have to, for that part, we would have to calculate v0x, and it'll be the same way we calculate v0y, except that we're going to use cosine of the angle. So v0x is equal to v0, which was 30 meters per second, times cosine of 36.9. Okay, which is equal to, I'm not quite sure, let me check on a calculator. Okay, so about, well, it's 23.99, but let's say 24. Okay, so 24 meters per second is the component of the the x component of the velocity at both times, because that is the velocity at all times. The velocity never changes in the x direction. Okay, so you got that. Oh, and this is part B in general. Okay, so now let's see. Now for the y direction. So we're going to say Vy is equal to, okay, so that should be V0 Y. Okay, so it's plus GT, but it's minus because A sub Y is negative G, as we said in the beginning. So minus GT, because this is the final velocity is equal to the initial velocity plus the change in the velocity with respect to time and everything. So the the velocity is changing by a certain amount, so the difference between the initial velocity and the final, and the change in velocity, in this case is difference because it's a sub y is equal to negative g. But yeah, so that's essentially what it is. The final velocity is the initial velocity plus any change in the velocity. Okay, and in this case, this negative, this minus just indicates the direction. Okay, so let's say now that Vy is equal to, well, V0y, which was 18 meters per second, okay, minus 9.8 meters per second squared times 0.69 seconds. Okay, so that is equal to, let's see, it's 9.8 times 0.69, 0.69. Okay, so 6.76 minus C2, so about 11.2, let's see. Okay, so it was about 11.2 meters per second in the plus y direction, because remember, up was the the plus y direction was up, so the ball was going up. When the batter hit the ball, it was going up into the plus y direction, so this 11.2 meters per second is positive, okay, as we would think it would be. Okay, so at 0.69 seconds, the y component of the velocity was 11.2 meters per second. So now let's see the y component for 2.99 seconds. It's the same thing, except we just substitute 2.99. The y is equal to 18 meters per second minus 9.8 meters per second squared, okay, times 2.99 seconds. Okay, so let's see what that is. Okay. Alright, so we got 11.3. Negative 11.3. And it's negative, as you can imagine, because at the second time that the ball is at 10 meters, it's going down at that point. So the negative indicates that it's going downwards. Okay, so that makes sense. Okay, so now we can start part C. Okay, so part C, we're trying to figure out the components of the velocity. Let's see, the magnitude and direction of the baseball's velocity. So we have to figure out the components of velocity so we could, of the x and y velocity, so that we can find the magnitude, just the general magnitude of the velocity at the time when the ball returns to the level at which it hit the bat. At which it hit the bat. Anyway, so now basically what we have to do is we're going to, well, let me actually just get rid of this stuff because we're doing part C now. Okay, so this is part C. Alright, so now we're going to do the same thing that we did before with the y distance equation, except instead of 10 meters, we're going to have 0 meters. Okay, so 0 meters because the point at which the the ball hit the bat, the bat hit the ball and sent it into the air, is that horizontal point is 0, or that height, I should say, is 0. Y is equal to 0. So it goes up in a parabolic motion, then it comes down back to a height of 0. So we want to try to figure out that second height. So we know that at t is equal to 0, that should be one of the times. So now the second time, well, we know, so let's just calculate this. So we're going to have v0y, which was 18 meters per second, times t. Okay. And then minus 1/2, 9.8 squared. Okay, times t squared. Okay, so we have to just solve this quadratic equation for t, and once we figure out the times, the two times that that the baseball was at y is equal to 0, then we can plug that into the velocity equation, and then we can calculate the magnitude of the velocity. Okay, so let's see now. Okay, so once again, I'm going to write it in descending order. So negative 1/2 times 9.8 meters per second squared times t squared plus 18 meters per second times t. And that's equal to 0 meters. Alright, so, well, let's just see. Now we have t is equal to minus b, which is minus 18 meters per second, plus or minus b squared, which we said was 300, what was it, 324? Yeah, 324, square root of 324. Okay, so minus 4ac, so it's going to be minus is going to be plus this time. So plus now, well, that's just going to be 2 times 9.8, 19.6. Okay, all divided by 2a, which is going to be negative 9.8. And I realize that I keep forgetting to write in the units under the radical there. Sorry about that. Okay, so now, once again, let's see. Okay, well, so now negative 18 divided by negative 9.8. Okay, so 1.84, like we got last time. I don't understand why this is not making a point. Okay, so plus or minus. Okay, so the square root of 324 plus 19.6. Okay, so that's 18.5. Oh, well, 18.5 divided by 9.8, negative 9.8. Okay, so it's negative 1. Let's say 1.89. Okay. So t is equal to, alright, so let's say 1.84 Oh, wait, this is negative, right? Okay, so 1.84 plus minus 1.89. Okay, which would be a negative number, which we won't actually use, but just to write down, 0.05 seconds, negative 0.05 seconds. We will not use that. Cross that out. And the other one, which will be negative times negative is positive, 1.84 minus 1.89, so it's plus. So it's 3.73. Okay, so these are the two times, but the negative refers to a time before the ball was hit. So that doesn't make sense in the context of this problem, so we're just going to use 3.73 seconds. So now we're going to plug in 3.73 seconds. Just get rid of this stuff because we already calculated that. Well, we can use that part. Okay. So let me get back to the pencil tool here. All right, good. Okay, so now we've got the time, the second time, because of course 0 is the first time that it was at level, or it was at the level that the ball hit the bat, or vice versa, relativity. All right, so the second time is 3.73 seconds later. All right, so now we plug that into it. So remember that the velocity, the component of velocity in the x direction is always 24 meters per second. That doesn't change. So we just have to calculate the component of the y velocity at 3.73 seconds. So Vy is equal to V0y, so it's 18. That does not look like an 18. 18 meters per second. Okay, minus GT, so minus 9.8 meters per second squared times T, which is 3.73 seconds. Okay, so now what is that, you ask? So let me tell you. Okay, let's see, 9.8 times 3.73. Okay, so negative 18.6 approximately. Okay, that's enough. Well, it's supposed to be. Alright, so, well, that makes sense. It's negative, so it means it's going downwards. And at that point, it would be going downwards, the ball. Okay, so now we can say that V is equal to the square root of, well, that's Vx squared plus Vy squared. Doesn't really look like a 2, but it's a 2. Okay, which is equal to the square root of 24 meters per second squared plus negative 18.6 meters per second squared. I'm having a lot of trouble with this pen. Okay, and that is equal to, let me see. Mm, 30 meters per second. Okay. Alright, so, well, it was hit at a velocity of 30 meters per second at t is equal to 0 and at t is equal to 3.73 seconds, which is the second time that it was at the same level at which the bat hit the ball. The second time the ball was at that level, I should say. It was back down to 30 meters per second. But we have to remember that I should have written it down before, but this is plus or minus, because plus or minus square root of something, but we take the negative one because it's going downwards. So it's going to be the square root of whatever that is multiplied by -1, which is just negative 30 meters per second. So it's going downwards at 30 meters per second at that point. Alright, so I hope you all learned something, and I'll see you in my next video.